Okay, so using the CUNY Virtual Console, I'm going to quickly jump into Maple, and I'm going to show you really quickly a Riemann sum on Maple. Okay, so this is something that you will see in your Maple class. Your instructor will most likely show you this. Um, so I'm going to use Maple to plot a few um, Riemann sums, in particular the example that we just did in the part right before this one. So let me see if this actually erases. All right. Come on, Maple, don't mistreat me today. There we go. So with, we first start by calling the package with, actually it's not with plots, it's with students, with student calculus. Yeah. There we go. This one. This should work. Let's see. There we go. So we got all of our commands, and now we're going to use the Riemann sum command. So Maple actually has a Riemann sum command. Riemann was a person. He was a German mathematician. That's why his name gets capitalized. So anyway, the function that we had earlier was, I believe it was negative x squared plus 5. So let's see, negative x squared plus 5. And we're doing this from x equals 0 to 2. Let's see, what else? So we first did the left sum. So let me see if I write left. And then output equals plot. So this should plot the sum. Let's see. Actually, don't want to do that. Let's see. Actually, I want to do one more thing. Partition equals 5. We have 5 of them. Okay, so I press enter and I get a much better picture than what I had before. So this is the left Riemann sum of what I had drawn on my paper. So you could see that there is some overestimation in all of the sides, and you could see the actual approximation right here. It's 8.08. So this is a left plot. If I go now and I go into the right plot, into the right sum, notice that now I have the underestimation, which is what I had on my paper. Notice how this is an underestimation, 6.4. So we know that the actual area of this is between 6.48 and 8.08. Now, there is another method, which I'm going to get into in the next part of this lecture, which is the, is it middle or midpoint? I always forget, midpoint. It's midpoint. So it's a midpoint method as well. It gives us a better representation because instead of taking the left side or the right side, we take the middle portion of the interval. So now you see that there's some underestimation and a small overestimation for each of them. So there's an underestimation, overestimation for each. Let me actually plot all of them at once so you can see them all. So that was midpoint. Let me do right So notice that on the right side again, there's some massive underestimation. Here, there's some under and then some over. So hopefully this makes up for most of it. And notice how this is more accurate. This estimation is closer to 7.36. So now we know that this is actually much closer to what the actual area is. Now, if we increase the number of partitions, which is the reason why I wanted to use Maple, so that it looks better. We use 5 partitions for this. Now, what if I use 10? If I use 10 partitions, notice that now my estimation went up to 6.92. And notice that the underestimation is much smaller than before. If I increase the number of partitions to 100, and I'm allowed to do this, I'm allowed to put as many rectangles here. Notice how accurate this became. You cannot even tell by the naked eye if there's any overestimation or underestimation with 100 partitions. And notice how close these two numbers are. We have that the approximate area is 7.29, whereas this one, just 5 partitions, is 7.36. So let me take this back to 5, and now let me go this one with 100. So we have that with 100 midpoint partitions, we get 7.33. So I'm pretty sure the area is between 7.29 and 7.33 as far as our approximation goes. I am going to show you how to do these approximations by hand in the next part. The example that we did was more to get our feet wet. In the next example that I'll do, we will actually compute these things by hand using left, middle, and right sums. And this is what we call a Riemann integral. I'm going to define this, not a Riemann integral, a Riemann sum. I'm going to define this in the next section as well. Maple is very useful. You are certainly welcome to use Maple on your homework to solve some of the problems, although I prefer that you do it by hand because your final exam, you should really only be using the knowledge that you learn in the classroom, even in this virtual setting. In any case, that is all for this real quick piece.